we are starting on page, what? 18. Okay? All right. Now, we're going to talk first about synthetic substitution. Okay? This is used to find the value of a function. Basically, take a look. We have seen this type of problem so many times. Find f of 3 if this is f of x, right? But we're going to now do this in 3 different ways. The first thing is by direct substitution. This is how you've always done it, right? So that would be 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. 3 times 27 minus 6 times 9 minus 8. This is 81 minus 54 minus 8. So f of 3 is 19. Okay, not bad, right? Nothing new. Now, how about if we do it by long division? Okay, turns out you can also do it by long division. How does that work? So my x value here is 3. So if x is equal to 3, right, and you have a factored equation and you want to solve it and you get x equals 3, what factor does that come from? That comes from x minus 3, right? Yeah? So first, that's how I write this. And now I want to divide x minus 3, 3x cubed minus 6x squared plus x minus 11. So here, first term divided by the first term, 3x squared. So here I get 3x cubed minus 9x squared. Change the signs. 3x squared plus x. What do I put here? 3x. So I get 3x squared minus 9x. Change the signs. 10x minus 11. What do I get? I get 10x minus 30. Change the signs. Ooh! And it's 19. Look at that. The remainder is f of 3, right? So this remainder is f of 3. Oh my God. That is so cool, right? We'll talk about why in a minute. But so now you're like, okay, wait, if I could do it by long division, I could do it by synthetic division as well, correct? The answer to that is yes, yes, yes.
If you, wait, actually.
Okay, so by synthetic substitution, now we're going to do the same thing. Here, we're going to put the 3 as is. And here we're going to put 3, negative 6, 1, and negative 11. 3 comes down, 9, 3, 9, 10, 30, 19. Voila, f of 3 is 19. Magical. And so now some of you are like, you know what, Ms. Malikan, this is fine. But like, I mean, I had no problem doing it like A, right? A method, like direct substitution. Correct, because we were finding f of 13. What if you wanted to find f of negative 18? What would you have done then? Were you really going to square? Like, right? It's so much more, like if you don't have a calculator or whatever, like you're not going to be doing 18 cubed and 18 squared. This, however, is a lot more efficient. Okay. Now, so what did we notice? The same value for f of 3 is obtained by all 3 methods. Okay? So I don't know much about how the graph of this function looks. All I know is f of 3 is 19, right? So that means here, okay, I don't know what this function is going to do everywhere. But when I'm at 3, f of 3 is going to be 19. Okay? So this is Okay? 3 and 19. And so now, right? Now, what if, right? What if somewhere down the line here, I don't know where, there was a point on the x-axis, right? So then what would the y value be there?
The y value.
Yeah, here.
Zero.
The y value would be 0, right? And how did we get the y value? It was the remainder of the division, correct? So here, if I were to divide here, what would the remainder of that division problem give me? 0, right? Whatever this is x comma 0. Let's pretend it was like 9, right? Then it would be like 9 comma 0. So if I divided, right, if the factor was x minus 9, right, and if I divided by the 9, I would get 0 remainder there. Okay? Okay. All right. So let's talk about the factor theorem for a minute. Okay. If I divide something and get 0 remainder, like if I divide 24 by 3 and I get 0, what does that mean about 3 and 24? What is 3 of 24 then? It's a factor of 24, correct? So if I were to divide by x minus 9 and I get remainder 0, what does that mean? That means x minus 9 is a factor of that function, right? And so when I factor it, I should get x minus 9, all right? That is the factor theorem. So when a polynomial division produces the remainder 0, the divisor is a factor of the polynomial, and the quotient is called the depressed polynomial. Okay? All right. So here, determine if x minus 3 is a factor of this. So, okay, so like if I wanted to find if 7 is a factor of 24, I would try to divide, and if I don't get a remainder, then it's a factor, right? So to do this, first, I'm going to have to divide this. So let's do that. So we have x minus 3, which means x equals 3. So let's do this division. We get 1, 4, negative 15, negative 18. So here, 1, 3, 7, 21, 6, 18, 0. Oh my God. Yes, it's a factor, right? Because f of 3 equals 0, it's a factor. Well, what's a factor? X minus 3 is a factor. Okay? So now, it says here, if it is a factor, identify the depressed polynomial. The depressed polynomial comes from here. That is x squared plus 7x plus 6. And then find the other factors of the polynomial. So now I can rewrite my f of x. Here is how I rewrite my f of x. This one, right, that gave me a factor of x minus 3 times this. This is now one step factored from the original polynomial. Now I want to factor this some more. F of x is equal to x minus 3, x plus 6, x plus 1. There we go. Here it is. These are the factors of the polynomial. Okay? Yeah. I factored the red. Yeah? Okay, so now it says, then graph the function. Okay, so let's graph the function. Yes?
So anytime there's no remainder, then it's a function?
It's a factor. Yeah, it's a factor. Correct. So the zeros are x equals 3, x equals negative 6, x equals -1. Okay. What's the y-intercept? -18. Okay. All right. So here we go. The zeros are 3, -6, and -1. And then how about the end behavior? It's odd, yeah. So it's like here and this, right? And so, okay, so you know what? Maybe I can redo these. So I can make this a 10 and 20, -10, -20. So at 0 and -18, I have a y-intercept. Yeah? And so this is how this is going to look. It's going to come up, come back down, hit, come up, right there. Okay? Beautiful. All right? So you don't know it, but you just learned a fundamental theorem of math, right? You did. There are not a lot of fundamental theorems of math. This is like we're coming towards one of them, okay? And the fact that you now learned that x minus 3 is a factor when the remainder is 0, this is like a big thing. So let's move on. Given a polynomial and one of its factors, find the remaining factors of the polynomial. So here we go. Let's look at what the sentence says. Given a polynomial and one of its factors. We are given one of its factors. No question about it. So then when I divide by the factor, what should my remainder be? 0. Right. So let's do that. So here, this is the factor. X minus 1 equals 0. I get x equals 1 to put outside. So now here I got 1, -6, 11, -6. Right? So here we go. 1, 1, -5, -5, 6, 6, 0. Okay, so here, I always want you to write it like this. F of x is equal to. From here, I get x minus 1. From here, I get x squared minus 5x plus 6. So here it says to find the remaining factors. Well, I gotta go more, right? So f of x is x minus 1, and when I factor this, I get x minus 3, x minus 2. These are the factors. More often than not, sadly, students will be like they will, do this, and then you're in like autopilot mode, and then in the answer space, they will say x equals 1, x equals 3, x equals 2. Yes, it's correct that if you were to solve this, those would be the x-intercepts, but that's not what I asked you for. And in an honors level class, I expect you to know the difference between the intercepts and the factors. This is not what this question is asking you for. It's asking you for the factors. And then now we're going to graph this. So we got zeros at 1, 3, and 2. Oh boy, they are all like conspiring over there, right? End behavior, same as before. What's the y-intercept? -6. Always put the y-intercept. And, so that will like literally ground you a bit. And here, okay? But you're going to do it better than me, and you're going to actually pass through all those lines. Points. Yes?
It doesn't matter like how high, how low.
No, not for now. That's a calculus issue. Yeah. Okay, so find the remaining factors of the polynomial. Okay, let's do it. So all of these I should have f of x. Anyways, okay. So here, 3 out here, 1, -1, -5, -3. 1, 3, 2, 6, 1, 3, 0. Okay, let's pause here for a minute. You are told that x minus 3 is a factor. The math dictates that the remainder here will be 0. So if you do this and you don't get a remainder of 0, we, the humans, are the ones that made an error, right? This is one of those cases where the math is really bigger than us. And if the math dictates that it's going to be 0 remainder and we don't get 0 remainder, we messed up somewhere. Okay? All right. So now f of x is going to be x minus 3, x squared plus 2x plus 1. So this is going to be x minus 3, x plus 1 squared, right? Now, especially in honors, I do need you to recognize that that's x plus 1 squared, okay? And so don't put it as x plus 1, x plus 1. Combine it as x plus 1 squared because that has other implications later, okay? All right. So, okay, let's do this one very, very quickly. So -2, I want to do this because we can actually do this in two ways. So here we go, -2, right? We just need to find the factors of this, right? This is a wonderful way that works for any polynomial. So 1, 2, -1, -2, -2, 4, no. Oh my, I skipped a step. Oh my gosh. 0, 0, 2, 0. Fabulous. So here I get x plus 2. Here, x squared minus 1, right? And so when I factor further, you know, it's this lovely little thing. Now, this one is different from the one up here. The one up here, we really couldn't have done any other way. It had to have been this way. This one, though, is different. Why is this different? You know why? Should I tell you? What's special about this polynomial? So this one, you can actually factor it by grouping, right? So here I can factor out an x squared. Here, I take out a minus 1. And now, x plus 2 is the common term. X squared minus 1. So I get x plus 2, x minus 1, x plus 1. Okay. Is one more mathematically correct than the other? Absolutely not. For me personally, factoring is always just kind of like simpler. It's my go-to method. So before I do anything, I always check, can this polynomial be factored by, other means first? And then if not, then I go to these other things, okay? But I mean, honestly, either way works. Okay, take a look at this one. The approximate number of bald eagle nesting pairs in the US can be modeled by this function. Somebody went and did this, right? Where x is the number of years since 1970. Using synthetic substitution, estimate how many nesting pairs of bald eagles can be expected in 2018, right? So first of all, 2018, and if we started at 1970, this is 48 years. So what are we going to do here? What is it that we're looking for? Right, or P of 48. right? And we're going to do it using synthetic substitution. So let's go ahead and do that. You're going to need some space for this. Okay, so we got negative 0.16. Okay. 15.83. Negative 154.15. And this lovely number, random number. Okay. And then, okay, go ahead and take out your calculators. Let's do this. Negative 0.16 comes down. So what do we get? Negative 7.68. We subtract. All right, I can help you guys out here. We get 8.15. We multiply 391.2. We add 237.05. Multiply, it's a big number. And when we add 12,526.37, right? So P of 48 is 12,526.37. That means there are around 12,526 nesting pairs. Right? Super cool, right? Okay. So now, in the next lesson, we're basically going to put everything in this chapter together, right? So here we go. Let's review some vocabulary. We have this lovely function of degree 4 and its graph. We can clearly see that the zeros here are right here, these values, okay? And they're called the zeros because y is 0 at these points. So if I were to say p of x equal to 0, find the roots, those are this. Now, the roots and the zeros sometimes are the same. Sometimes the zeros are just the x-intercepts, right? And then like there may be additional imaginary roots, okay? So that's the distinction. Now, if these are the roots, then the factors are this. So you're always going to do x minus the 0, right? X minus the 0. Okay? And then the x-intercepts are given in this form, always. Cool? Cool. Okay, so let's solve and state the number and type of roots. So now, we have made it so far that there is now not a single polynomial on this planet that you will not be able to factor, right? Like that's a pretty cool thing, okay? So let's do this one. Starting off easy, right? Tell me, how does this factor? Oh, what do you guys think? There we go. So x equals -8, x equals 6. So we have two real rational roots. Okay, here we go. Our favorite difference of squares, x squared. What's the square root of 256 these days? 16. So plus 16 minus 16. Okay. So this is x squared plus 16. Can't factor that anymore. But this is x plus 4, x minus 4. So this, we set it equal to 0. Right? And you take a square root. X is plus or minus 4i. And the only reason why we did that, set it equal to 0 and use the square root property, was because it couldn't be factored. So here, x is plus or minus 4. So then I have two real, rational, and two complex. For a total of how many? 4. Can't have any missing. Okay. What do we do here? What do you think? Factor out the x. Okay, so from here, I know that x equals 0. Can the other one be factored? No. So now your choices are quadratic formula or completing the square. Why don't we practice completing the square? We haven't done that in a while, right? So here's what we're going to do. X squared minus 6x plus a number equals negative 7 plus a number. What number goes there? 9. X minus 3 squared is equal to 2. Honestly, sometimes, not sometimes, I actually prefer completing the square to quadratic formula. It's much cleaner. You're not doing 4 times a times b. Yeah. Okay, so take a square root. X minus 3 plus or minus root 2. X is 3 plus or minus root 2. So, I have how many total roots? 3, right? So I have one real rational, and I have two real irrational. Okay, what do we do for this one? Is it, huh? Yeah, say it. The difference of cubes. That's exactly it. We're gonna factor it. We are not gonna say this. We're not gonna do that. Okay? We're gonna factor it. Difference of cubes. X minus 2, x squared plus 2x plus 4. Oh, hello. X equals 2. Here, let's do completing the square again. So, x squared plus 2x plus a number, negative 4 plus a number. I'm going to go with a 1 this time. All right, let's do this. X plus 1 squared is equal to negative 3. Take a square root. x plus 1 plus or minus I root 3, negative 1 plus or minus I root 3. Look at that. 3 solutions, right? So now I have one real rational and 2 complex. Okay. Pretty fun, right? That's so much. I love this stuff. Like it's amazing. Okay. So that's one last thing. Okay. Sorry. Okay. Sharpen your pencils for this one. I mean, like, figuratively. Okay, so complex conjugates theorem. You have seen now, right, that when you have complex solutions, they never come alone. There is always a partner to it. Because where do they come from? They come from taking a square root of both sides, right? So naturally, it's always plus or minus, plus or minus. So you will never have 1 plus I root 3 as a solution. It's always going to be plus or minus. So complex solutions always come in pairs, which means if A plus BI is a 0, then its complex conjugate A minus BI is also a 0 of a function, right? So now we have to write a polynomial function given the zeros of it. So for this last one, I was given the polynomial and I came up with 3 solutions. Now I'm given the things in the circles and I need to come up with this. So let's do that. First of all, what are the zeros? 2, negative 3, 2 plus I, but alongside that, 2 minus I. Okay, so now, because we need to write a polynomial function, we're going to start with f of x. Okay, from the first root, x minus 2. Second root, x plus 3. Third root, I'm going to do a bracket, x minus 2 plus I, x minus 2 minus I. Okay, now, this easiest thing we've done all day, right? X squared plus x minus 6. Get that out of the way. Now, here's what we're going to do here. You're going to distribute this, okay? But keep the brackets. Go with me on this. Nothing major, right? Okay, now I'm going to reintroduce the parentheses. But this time, do you see how both of them have x minus 2? We're going to group the x minus 2's together. Okay. Can we see what we have now in those ugly looking brackets? If I had... Oh, look at that. So if I had x minus 3, x plus 3, what would you have done? Well, no, but like if you were to multiply them, what would you have done? You square the first one, you square the second one, and you put a minus in the middle. Well, that's if you have x minus 3, x plus 3, right? Here you have this minus I, this plus I, right? So what we're going to do is this. First, let me write this over again. Look at what we're going to do. We're going to have this first one squared minus the second one squared. And how are you going to remember to do that? You're going to practice. Okay? So x squared plus x minus 6. Okay, here. How do you square the blue? Tell me. What do we get? X squared minus 4x plus 4. Yeah? Now, minus, what's I squared? Negative 1. So this is x squared plus x minus 6, x squared minus 4x plus 5. Guess what we're going to do now? Multiply them! Okay, let's do it. So first, I'm going to distribute an x squared to everybody. So that's x to the 4 minus 4x cubed plus 5x squared. Then a plus x to everybody. Then a negative 6 to everybody. Then combine like terms. So x to the 4 is alone. Minus 4x cubed plus x cubed minus 3x cubed. Okay, where are my x squares? 5x squared, negative 4 is 1, minus 6, minus 5x squared. And then what do I have? 29x plus 30. That is your f of x. And now, that's it. We're done. That is your f of x. So now, if you are factoring this and solving it, you would get as your answers 2, negative 3, 2 plus I, 2 minus I. Right? How many factors, how many zeros did we start with? How many zeros did we have? 4, right? What's the degree? 4. Okay? So this is it, right? Look at this. We have arrived. Isn't this super, super cool? This is like the coolest thing ever. Okay. So, all right. One sec. Okay.